Welcome, and thank you for joining us today. I am pleased to introduce our architecture firm, Tiscareno, and shed light on a pressing topic, the impact of recent Washington State Energy Code updates and how this is adding increasing complexity to mid-rise construction with an emphasis on the mandate to use energy recovery ventilators, ERVs, in residential construction. In an industry where precision is paramount, code regulations are in a constant state of evolution, and energy efficiency is a requirement. We are acutely aware of the challenges faced by real estate developers and general contractors as they navigate the maze of building codes and energy performance standards. Today, we aim to explore why these new energy regulations are moving mid-rise engineers and architects to adopt coordination and pre-planning techniques that were traditionally reserved for high-rise construction and more complex building types. The implications of this shift are far-reaching, impacting cost control and project timelines. In the 2018 Code Cycle Revision, Washington State mandated the inclusion of energy recovery ventilators in mid-rise construction. ERVs are a component of the ventilation system designed to optimize energy efficiency and indoor air quality. In the past, various approaches were taken to provide fresh air, such as operable windows, trickle vents, and HVAC systems with traditional intake and exhaust vents. The downside to these earlier approaches was that heat created to keep the occupants comfortable was lost during the fresh air exchange process. During the process of replacing stale indoor air with fresh outdoor air, ERVs operate by balancing moisture and exchanging hot or cold air. This dual function reduces the energy load on heating and cooling systems while ensuring healthier and more comfortable indoor environments. ERVs are now a fundamental component of mid-rise construction in Washington State. The inclusion of ERVs in multifamily projects introduces a new level of pre-construction coordination, requiring seamless collaboration among key stakeholders to minimize schedule and cost disruptions. ERVs are located inside every residential unit in the building, thus requiring routing coordination of ductwork with exterior envelope penetrations and other disciplines work, such as structural and mechanical consultants. Coordination with the structural engineer is required to ensure ducts can be routed to the building exterior without conflicting with shear walls for lateral bracing or other items required by the engineer to support the building. Mechanical engineers keep abreast of and recommend appropriate equipment with the new models coming onto the market regularly. It is vital to address potential conflicts early in the design process. This ensures that the installation of ERVs and associated ductwork does not interfere with other critical construction activities, thus reducing the risk of delays and cost overruns. Early coordination can result in a smoother construction process, on-time project delivery, and cost savings if well planned. To achieve this level of coordination, tried and true techniques can still be incredibly valuable, especially when it comes to initiating the coordination process. Take, for example, the use of checklists. These simple yet effective tools help teams identify potential issues early on, serving as a proactive approach to problem solving. By systematically verifying critical items, teams can trigger important questions that, when addressed promptly, eliminate possible hurdles down the road. Additionally, well-timed quality assurance, quality control, QA/QC reviews can uncover potential issues and discrepancies that might have otherwise gone unnoticed. Team meetings reviewing document overlays between disciplines can reveal clashes, which, when caught early in the design process, can reduce scheduling issues for installation during construction. The architect plays an important role involving ongoing review of the team's work and directing new efforts as needed. Their experience and expertise are instrumental in ensuring that all aspects of the project align seamlessly and that potential problems are identified and resolved before they can escalate. The adoption of building information modeling, also known as BIM, and online collaboration tools have revolutionized the collaboration process, enabling real-time markup and coordination across disciplines. Now, discussions and decisions are shared online and scrutinized across all affected disciplines. This prevents issues from compounding and reduces the need for extensive rework. By using BIM, project teams can achieve new levels of speed and detail in their coordination efforts. This not only enhances efficiency, but also ensures that ERV-related considerations are seamlessly integrated into the project's overall design. The future of successful coordination relies on embracing these technological advancements to create a streamlined and error-free construction process. The following images are from one recent project example of an ERV installation. At the 164th Street apartment project, we had to closely coordinate with the structural engineer to determine routing for the ERV ductwork so as not to degrade the structure itself. In addition, the ERV itself is no small unit. This fact alone required structural coordination to allow for room to mount the unit within the joist space. Once a solution was found, this detail was able to be repeated throughout the building. After a building and mechanical code review in consultation with the local jurisdiction, the architect and mechanical engineer were able to determine what would be required to route the ERV and ductwork within the joist space. Using the solution led to fewer or no ceiling fur-downs in the apartment, which allows light to penetrate deeper into the unit itself. Here, a radiation damper was required to allow for the solution. Once routing was determined by the structural and mechanical engineers via rigorous coordination, the architect had to verify the clearances required by code for the ERV inlet and outlet were met at the exterior of the building. A new combination ERV exhaust termination and intake on the market was used, helping alleviate some of the overlap. The ERV unit was located as close to the exterior wall as possible, which helped reduce structural conflicts. In this example, the first joist bay in from the exterior wall was sized to accommodate the ERV unit, thereby greatly reducing the intake and exhaust duct runs. In conclusion, the key message is that to ensure successful integration of ERVs into a project, it is essential to begin the coordination process much earlier than has been standard procedure for most multifamily projects in the past. Earlier involvement by a sub-consultant engineer permits better integration of all the building systems, including ERVs, which has the potential to avoid costly changes in the field and schedule delays. Embracing this proactive approach has the promise of better coordination and more economical construction. Thank you for joining our exploration into this new crucial aspect of multifamily design and construction.